Hello guys, welcome to C Learning with new video. In this video, we will learn about BGP attributes. So in my previous videos, we learn about BGP, how to configure BGP, how to configure BGP peer, IGP peer, and eBGP peers. So in this video, we will learn about how to use BGP attributes to control routes in BGP. So there are many attributes in BGP. So far we use in this video we will learn about how to use local preference to local preference attribute to control the route. So mostly local preference is an attribute that is when we import route in BGP autonomous system, we use the local preference to control the route. So first of all, I will complete the layer 3. I will give the IP address to interfaces. Then we configure our peers, ABGP and IBGP peers, and after that we configure the attributes. So we use the same topology in next attributes. So first of all, we use the local preference. Then on this same topology, we will use MED and other attributes in our next videos. So once you create the topology, save this topology, and we will use to play the same topology to configure our other attributes. So first of all, I will give the IP address to all the interfaces. So let's go. This is R1 system view, system name. So system name is R1, and now we have two loopback interfaces on this R1 and two physical interfaces. So we'll go in physical interfaces first. G000 IP address is 10.1.1.1 and 24, and now we go on G001 and IP address on this interface 10.4.4.1 and 24. Now we go on interface loopback 0, and the loopback 0 IP address 1 and 32, and now we have loopback, another loopback 1. IP address is 11.11.11.11 and 32. So these are our address on this interface. Now we go to other system router 2. In system view, system name is R2, and now we have on this router we have the two interfaces, one this and other one this, and we also create a loopback interface on this router 2.2.2.2 on this router as well, 3.3.3, 3.3.3. So G0/0/0, which is this interface. So we'll get IP address. IP address is 10.1.1.2 and 24, and this interface G001 IP address is 10.1.12.2. We'll use 2 on this interface and 1 on this interface, 24, and also we have the loopback 0 IP address 2.2.2.2 and 32. Now we go on this interface and system view, system name is R4 and interface loopback 0, and IP address on this interface is 4.4.4 and 32. Now we go on physical interface giga. IP address on the 00 is 10.1.23.1 and 24, and the G001 IP address is 10.1.12.1 and 24 on this router as well. System view, system name is R3, interface giga 0/0/0. IP address on this interface is 10.4.4.2, 10.4.4.2 and 24. On G001 IP address is 10.1.23.2 and 24. Now we have loopback interface 0. IP address on loopback is 3.3.3.3 and 32. Why I am giving this loopback interface IP? because we use this loopback in IBGP when we create IBGP peer between this same autonomous system. This autonomous system is 200 autonomous system. In this autonomous system, we use the logical interface, loopback interface to create the BGP peer, IBGP peers. So if you don't know about how to create, so just go watch my previous videos. In this video, I will also create the IBGP peer. So our routing has been complete. Now we configure OSPF, any routing protocol in this to configure routing protocol that our router should be reachable to one another, because this is the our end of our ISP. So we will not consider these interface in our local routing. So we just uh, take these interfaces, and our internal routing should be complete. So we use an internal routing protocol. So I will use the OSPF. So I will use OSPF 1 area 0, and the network should be this network 10.1.12.0 and 0.0.0.255. So this is our network here. So another network is loopback network is 2.2.2.2.2 and 0.0.0.0. Here as well, OSPF 1 area 0, the network is 10 dot sorry, yes, 10.1.23.0.0.0.255, and one is this one, the 12 dot network, which is this one and this loopback interface. So three network will broadcast in this routing protocol, OSPF. So display this. So confirm this by display this. So you can see here three network are here. So now we go. I'll just copy this network because use sorry this one. Use this one here as well. So OSPF 1 area 0. So network our is 3.3.3.3 and 0.0.0.0 and this. So now let's so you can see here the BGP states has been exchanged, and now it's BGP full state with this router. So we will wait here. You can see here as well. So now we'll ping here from R3 to R2. Let's see, our routing is complete. Ping 3.3.3.3, which is this one same. So let's ping 2.2.2.2. So let's see. Yes, let's ping 4.4.4.4. Yes, our routing is complete in our AS 200 and in our local area, in our autonomous system. Now our routing has been complete. Now we move toward the BGP. So how to create BGP? So first of all, we have to create the IBGP relationships. So BGP, when you create BGP, so first of all you create a BGP IBGP relationship within the autonomous system. So here we create IBGP relationship between R2, R3 and R4. Then we configure eBGP relationship between R3 and R1, and then R2 to R1. So this is our external eBGP peer, and this will be our IBGP peers. So let's start to configure BGP from this. So just go in R2. So this router is in uh, AS 200. So we configure BGP 200, and now we told this router its IBGP peers. So its IBGP peer are R4 and R3. So peer, we use this loopback interface to establish this IBGP peer. So we use these IPs, logical loopback IPs. So for AS number is same, and also we have a second command for this peer 4.4.4.4 in connect to loopback 0. We have to tell that it's connect with loopback 0. We also tell this as your peer is 3.3 within same autonomous number, and also peer 3.3.3.3 in same AS. Sorry, connect with loopback 0. connect with loopback 0. So this command we use here as well, so I just copying this command here as well. Just go in BGP 200 and tell him the peer is 3.3 this one and 2.2.2.2. Oh sorry, with same autonomous number, peer 3.3.3.3 in connect to loopback 0. Also have peer 2.2.2.2 and AS number is 2. Sorry, AS number is 200. Also peer 2.2.2.2 connect with loopback 0. So just go here, BGP 200 peer 2.2.2.2 AS number 200 and peer 2.2.2.2 connect with loopback 0. It has a peer 4.4.4.4 AS number is 2 and peer is 4.4.4.4 connect with loopback 0. So let's verify its peer. So just have we have a command display BGP peer. So let's see. You can see here on this router R3 we have R4 peer and R2 is a peer. So you can see here 2 to 2 and for still in idle conditions. So after some time when the BGP states establish, you can see here that there are different BGP states. So here from down to it's open, confirm, establish, and it's exchange the BGP states. After changing it will up. So you can see here now its BGP state is established. Firstly it was idle and now it's established. So we confirm from here as well. Display BGP peer, sorry, display BGP peer. So you can see here the peer is established from here as well. Display BGP peer. So you can see here the BGP peer is 2.2.2 in the same AS 200 and you can see here the status is established. Now we configure the eBGP peer with this. So this R2 will configure eBGP peer with R1 and R3 with R1. So first we are in BGP. So we tell this peer BGP peer. So now we will not use this logical interface when we configure eBGP peer. So we use this physical IP address to establish the peer. So we use this physical IP address 10.1.1 and AS number is 100. So this is the 100 AS number. So we will tell this that its AS number is 100. So we do not have to give the second command in this when we configure uh, eBGP peer. We do not have to give the command loopback because we are not using the loopback. So same this command we will use. Sorry, so I have used. So now I will go here. So here I will also use system view in BGP 100 because this is in BGP 100. Now we'll tell this the peer is 10.1.1.1.1. So this interface is 10.1.1.2. So we 2 AS number is 200. So here as well we will use this as well. So peer 10.4.4.2. This interface is 2. This interface is 2 and AS number is 200. From here as well, peer 10.4.4.1 and AS number is 100. So this interface is 10.4.4.1. So now we configure. So just use this same command display BGP peer. So you can see here another peer has been added 10.4.4.1 10.4.4.1 and its AS number is this one and still it is in idle conditions. So this is the time when it established the relation. So now it has been 6 seconds, so it's still in idle. After some time it will go up. So let's check this. So this has been up. You can see here the BGP state is now up. Sorry, display BGP peer command So you can see here this BGP pair has been established. So its autonomous system is different. So you can see here it also established. So now here display BGP pair. So now you can see pair has been established. Now we'll go. So now our peer has been established. Now we'll go give them the network. So what are the network they are using? We will exchange the route. So you can see here, you will observe that now our relation uh, eBGP and iBGP relation has been established. But if we see display BGP routing table, so now you can see here this routing table is still empty. So here as well on R4, if you display BGP routing table, so routing table is still empty. So we use different type uh, commands to import the route, and then we route will be exchanged. So we use different command, uh, direct command and import command, and then the network command. So I have used these all command in my previous video, so I will not use all these command to import all the route. I will just control the route. I will just import one route and then control that route via BGP attributes. So here I will use local attributes. So now you can see here I just advertise this route in BGP. From here I will R1, I will just advertise one route. So now on R4 you are seeing that there is no route present. So I will just advertise this route network command. I will go in BGP, and then I will via network command I will import a route, advertise a route. So I will route 10.132. So this is the route, loopback route I am advertising. So now you will observe display BGP routing table. Now you can see here is one route present. On R4 you can see here, so this route is coming R1. I have advertised this 1.1.1.1 route. On this route on R4 is coming through two routes. This route R1 on this is coming from this path and this path. You can see here on 10.1.1, which is this one, and 10.4.4.1. So from this path, so R4 receiving this route via two paths. So we will filter that route, that this route should be come from this side. If I advertise this another route, so this route will go through this one. So you can see here the first it's coming from this one, so it's R1. So I will control this route. So here I'm advertising another route in R1, which is 11.11.11.11.11 and 32. So now you will observe display BGP routing table. So now you can see here 11.11. Coming from this path as well. So 11.11. So its local preference is 100, so that's why it's coming from these routes. So now we'll change this local preference and change their path. So we'll use that, we will tell this preference, change this preference with link preference value, and tell that this route 1.1.1 should come through above link, and 11.11.11 should come through this link. So now we configure attributes via policy. So we will configure the policy on this interface, because this is the ASBR, autonomous system boundary router. So we'll write a policy, configure a policy here, and tell this policy that increase their preference value. So just 1.1.1 should come through this link, and increase the preference value for 11.11.11.11, and tell this router that increase the preference for 11.11.11, and decrease the preference for 1.1.1. So preference value, more the preference value for a route, so route will follow that path. If on a path the preference value is low, so route will not follow that path. So I will increase the preference value of 11.11 on this path. So 11.11 will not follow this path, only 1.1.1 will follow this path. So let's go. In system view, we have first of all we configure ACL 2000, and here we'll give the any route that we are giving the high preference value on this route 11. So 11.11.11.11 0.0.0.0. Sorry, I have didn't use source this one, source this one, and quit. Now I will configure the route policy. So route policy. Now I will give the name of route policy. So network 11, and here I will configure permit and node. So these are the you have to select the node, because you have to add if you are using the ACL, and you can apply different uh, route policy on the same path, so you have to use the different node. So node 10, now the node has been added. Now if match, so we'll give if match ACL 2000. So we are giving him the condition that if this route policy match ACL 2000, means ACL 2000 is 11.11. So just increase its policy preference value, apply local preference, increase 2000. Normally the local preference default value is 100, so we are just increasing the value of local preference. If it match the ACL 2000, in ACL 2000 we have the network of 11.11.11.11. So just apply this local preference, increase this local preference, and just command. Now we go in BGP system view, BGP BGP 200, and we have a peer. So we will apply this policy on this interface, that uh, this peer, if this from this peer this network is coming, so increase its preference value. So 1.1.1, peer is 1.1.1, which is this one, and apply the route policy on this network 11 and import. So now you will observe here display BGP routing table. So now you will observe, you can see here 11.11.11 value has been increased on this path. So 11.11 from this path 1.1.1, its value is 200, and 1.1.1 have the value 100. So we will also give the uh, route policy, route policy. So we just apply the condition here, route policy network 11 and permit with node 20, and apply by default. If we are not giving the condition here, so we are say that previously we said that if match ACL 2000, if match 11.11, so increase its preference value. Now we are not giving the condition, we just saying that if this policy, if we apply this policy somewhere, so its default local preference should be 1000, and you can see here. So now you will go here, so you will see this route. So you can see here 11.1.1.1 from this path, for this network coming from this path 11.11 with the preference is 1000. So you can see here, and 11.11 this network following this path, this one with preference low, but 11.11 with our path have a preference value 2000. So we also increase this value, this path. So one of route will follow this path, and now we have increased the 11.11 preference 2000 on this path and 1000 on this path, and now we increase from here. We also apply policy ACL 2000 rule permit source 1.1.1.1 and 1.1 and 0.0.0.0. So now we go route policy network for network 1, network. So you can give any name, permit and node 10, and if match ACL 2000, which is 1.1.1. So increase its preference value. So apply local preference value to 2000 on this path. On this path, 1.1 have the value 2000. On this path, 1.1 has 1000. So 2000. So just go back, and then we also use the route policy network 1. So permit node 20 and apply local preference 1000. uh, if other network is coming through this path, so just give that route the preference of 1000. Now we go in BGP 2000 200, sorry, and here we will apply this route policy on this interface. Here 10.1, sorry, 4.4.1, and then we apply the route policy network 1 on import when importing route. So now you will observe the impact on this router. So I am opening, so just note this one. So I'm repeating this command so you can see the impact. Now you will observe the impact. First, the 1.1 was following this path because it has the low preference, and now 1.1.1 is following this path with low preference. So now you can see here, firstly the 1.1 was coming from this path 4.4 with 100 preference. Now this 1.1 is following this path with 2000. So you can see there on 4.4.1 this route 1.1.1 on this route 4.4.1 the preference value has been increased, and on this path its preference is 1000. For this route 11.11 on 1.1 its preference is 2000. Still we have the confusion here that this route is I means these route are internal routes, but not are the best and valid routes. So there are other concept of best and valid route in BGP. So these are route coming to this router, but these routes are not valid and best, because their next hop is 4.4.1. If this route present here, so you want to go on this network 1.1 from 1.1, so its next hop is 10.4.4.1. Or if this route follow this path, this one for 1.1, which is this one, so its next hop should be this one. So then this route will follow this path, but still it's have this next hop is 4 dot. So to change this next hop, we have a command. So just go in BGP system view, BGP 200. So we just this we will run a command here, that peer 4.4.4, and use this local interface. So we'll give the command peer 4.4.4.4. So next hop should be its local. The peer 4.4.4 use this local next hop as their next hop, local interface next hop. So now if this command, I have given this command here, so now you will observe here, so this next hop will change to 4.4.4. After some time you will see the impact. So now you can see here, this route present here 1.1 has a next hop, this one, this loopback interface is the next hop. Now you can see, observe here, so its next hop is this one, and now you can see here its low local preference as above. So this path is now best and valid path. So you can see a star means the valid, and greater than sign means the best path. 1.1.1 his best path is 2.2.2 from this loopback. So you can see here, from here if we go the command peer 4.4.4.4 for next hop local, so it will use this next hop 11.11.11, because this path is valid with low preference, but it will not 11.11.11 will not use this path because this path is not valid. So this is the valid path. That's why this route is using this path with greater preference. Now we have given this command on this that the route, this peer can use this router as their next hop. So now it will change. So this how we can control route with BGP attributes. So now you can see here 11.1.1 is using this 3.3, 1.1 is using 3.3 with 200 preference, which is using this path, and 11.11.11 is using 2.2.2 because its preference value is high. So I have told you previously that higher the preference value, the route will follow that path. So 11.11, we increase the preference on 11.11 with 2000 on this path, so it will use this path. So that's how BGP works. So this with greater preference value, it will follow this path. Also this path is best and valid. So now you can see here. So that's how BGP attributes work. On this same topology we will see how to use same topology and how MED attributes work. So in our next video we will go for either MED attributes or AS path attributes. So do our next video. So thank you very much, hope you like the video, please subscribe.